Welcome to EnfinityCast, the show that decodes the future. I'm your host, Elion Quanta. Today, we're venturing into a realm that, until recently, was pure fantasy. The idea of talking to animals. But what if the key wasn't a magic potion, but a machine learning algorithm? Joining me to unpack this is my brilliant co-host, Solene Vox.
Thanks, Elion. It's a fascinating topic. The Dr. Dolittle's decoder, as some are calling it, isn't about magic. It's about massive data sets and sophisticated AI. We're moving from simply observing animals to actively trying to translate their communication, and it's yielding some incredible early results.
So let's get analytical. How does this actually work? Are we just feeding a supercomputer thousands of hours of whale songs and asking it to find a word for squid?
In a way, yes, but it's more nuanced. Think of it like this. AI models, particularly large language models, are masters of pattern recognition. Scientists are feeding them terabytes of bioacoustic data, the clicks of sperm whales, the chirps of prairie dogs, the rumbles of elephants, along with corresponding contextual data, like video recordings of their behavior.
So the AI correlates a specific sound with a specific action or event. It learns that chirp A is almost always followed by the appearance of a hawk, while chirp B happens when a human walks by.
Exactly. And the complexity is astounding. Research on prairie dogs, for instance, has shown their alarm calls can differentiate between predators. But AI is helping us see even deeper, that they might even be able to describe the color of a person's shirt or whether a coyote is approaching quickly or slowly. The AI can detect subtle variations in pitch and frequency that are completely invisible to the human ear.
That's incredible. And I've read about projects like SETI, the Cetacean Translation Initiative, which is doing this with sperm whales. Their codas, the series of clicks they use to communicate, are like a form of Morse code, and AI is trying to crack it.
It is. They're building a foundational dictionary of whale communication. But that brings us to the biggest analytical hurdle, Elion. It's the problem of correlation versus causation, or in this case, semantics.
Right. This is the core question. Does a specific whale coda actually mean there's a giant squid below us? Or is it simply a vocalization triggered by the excitement or sensory input of detecting a squid? Are we translating a language, or are we just creating a very advanced catalog of emotional reactions?
That is the billion-dollar question. And for now, we don't have the answer. The first step is to build these robust catalogs. The next and much harder step is to test for meaning. This might involve generating novel AI-created codas and playing them back to the whales to see if we can elicit a specific, predictable response. It's a painstaking process of forming a hypothesis and testing it.
The implications are staggering. If we can confirm semantic meaning, it would fundamentally change our relationship with the animal kingdom. It moves them from being objects of study to subjects we can potentially interact with.
It truly would. Think of the applications for conservation. Being able to ask a pod of whales where the best food sources are, or warning a herd of elephants about poachers in their own language. We're not there yet, but for the first time, the path to that future is becoming visible, all thanks to AI.
A new frontier of communication. Not in the stars, but right here on our own planet. That's all the time we have for today. Thank you, Solene. And thank you for listening to EnfinityCast. Join us next time as we continue to decode the future.